Today we'll study about POSIX IPC. POSIX stand for Portable Operating System Interface, which are portable and can be used across various Unix-like operating systems. There are various types of POSIX IPCs like pipes. Today we'll specifically study about pipes. Pipes are unnamed pipes and named pipes. Unnamed pipes are used for communication between related processes. Then we have queues, semaphores, which are used for synchronization between the threads and processes, and we have shared memory and memory mapped files. So today we'll start with unnamed pipes. We'll start writing our program. We'll include IO stream header for standard input-output operations. Then we will use uni-stdh for POSIX API like fork, pipe, read and write. Then sys/wait.h, which will be used for wait function to synchronize with child process. Then we'll have include cstring for standard length function, which we will be using to determine the length of the strings. Then we'll have our main function. We'll start by printing starting of the program. Then we will take a pipe file descriptor array of size 2, and we will start with pipe API, which is used to create a pipe, and it will return file descriptor pipe fd0 will be for reading and pipe fd1 index will be for writing. If it fails, it will return -1 and we'll be printing standard error pipe failed, and we'll have to return from here return 1. If it succeeds, then we will continue with our program. We'll take PID_T keyword, will fork one process which will return a PID. If the PID is less than 0, then our fork has failed. We'll print standard C error fork failed, and will return from here. We know that once the fork is executed, the child process and parent process will start executing parallelly. So if PID is greater than 0, it means we are in the parent process, because if fork succeed, it returns the PID of the child process. And we will close the pipe file descriptor 0. 0 is used for reading because we are not reading anything. We'll close the resource. It's good practice to close the resources or free up the resources which are not in use. Then we will print parent process writing to pipe, and we'll take our message SLP string literal pool. It will be stored in SLP. As you know, we are taking a pointer of character, and string literal pools can't be modified. Our message would be message from parent. We will use write API. It will accept file descriptor index1 for writing, then message our message, and string length message +1 for null terminator. And we'll close the pipe file descriptor index1 because we have written into the pipe. We'll use wait API so that our parent process waits for the child process to complete its execution. We'll print standard output message to our console: parent process has completed. Now we will go and take else case. If the PID is equal to 0, which means we are in a child process, we'll close the write pipe file descriptor because we are not using it, and then we will use read API to read the data from the pipe. So we will pass the pipe file descriptor. Buffer we have taken of size 100, so we'll also give the size of buffer. So this data will be read into the buffer, and now we can print whatever message we have received. Child process received message buffer. Then we can close the read pipe file descriptor once we are done using it. and will print cout child process has completed. Here we can see that unnamed pipe has been used for IPC inter-process communication, and the processes are related to each other because one is parent process. From parent process we are using fork to create a child process. So these processes are related to each other. If the processes are unrelated to each other, we can't use pipe, unnamed pipe IPC. Now we will see the output of this program. We'll execute it. Let's see what output we will get. We will run this program. Let's run, and let me scroll it up. Yeah, see, we are getting the output starting program. It comes into main, it will print starting program. Then the next statement is parent process writing to pipe. The pipe has been created successfully, and pipe FT0 will be used for reading, pipe FT1 for writing. Fork has also been succeeded. When the fork succeeds, we enter into the parent process, and parent is printing its statement parent process writing to pipe. Then it will store its message, and we will use write API to write the data into pipe. Then we'll close the pipe file descriptor and we'll wait for the child process. So once we are waiting for the child process is executing concurrently with parent, and child process will print child process received message, and the message whatever we have sent, child process has completed. Once the child process has completed, it will end and it will print program ended. Once it ends, we are waiting for the child process completion in parent. Parent will start executing. Parent has completed and program ended. Parent will also finish its execution. Thank you so much for watching.